Kepler 22b, the mysterious super-Earth we can't fully understand. What if I told you there's a planet out there, over 600 light-years away, that seems almost too perfect to exist? A world that shouldn't even be possible, yet it's sitting quietly in the vastness of space, teasing us with questions we can't yet answer. Meet Kepler 22b, the alien planet that challenges everything we thought we knew about the cosmos. Kepler 22b is no ordinary exoplanet. It's something of a cosmic enigma. Discovered in 2011 by NASA's Kepler Space Telescope, it's one of the most fascinating planets ever found outside our solar system. What makes it so special, you ask? Well, for starters, it was the first exoplanet confirmed to orbit within the habitable zone of a sun-like star. That's the sweet spot around the star where conditions might allow liquid water, an essential ingredient for life as we know it. But Kepler 22b isn't just another potential Earth 2.0 candidate. Its size, composition, and orbit have baffled scientists for years. In fact, it sits in a category of planets that we don't fully understand, worlds that are too big to be Earth-like, yet too small to be gas giants. It's a cosmic misfit, an anomaly that raises more questions than answers. Let's start with the basics. Kepler 22b orbits a star called Kepler 22, which is a G-type star, essentially a smaller and slightly cooler version of our Sun. The planet itself is located about 600 light-years away in the constellation Cygnus, which means we're looking at an object that's so far away, its light takes 6 centuries to reach us. Think about that for a second. When the light we see from Kepler 22b left its star, the world was in the Middle Ages, and nobody even knew the Americas existed yet. It's a mind-bending reminder of just how vast and ancient the universe really is. Now here's where things start to get really interesting. Kepler 22b is what scientists call a super-Earth. It's about 2.4 times the size of our planet, placing it in a curious middle ground between Earth-sized terrestrial planets and the gas giants like Neptune or Uranus. But that's where the mystery deepens. We don't know exactly what Kepler 22b is made of. Is it a rocky world surrounded by a thick atmosphere? Is it an ocean planet covered entirely by water? Or is it something else entirely? A type of planet we've never even imagined. Its size and location in the habitable zone make it a tantalizing candidate for further exploration. But the truth is, we just don't have enough data yet to answer those big questions. And speaking of location, Kepler 22b's orbit is another fascinating puzzle piece. It takes 290 days to complete a full trip around its star, which is surprisingly close to Earth's 365-day year. But Kepler 22b orbits at a distance of just 0.812 AU, about 81% of the distance between Earth and the Sun. That might sound dangerously close, but because Kepler 22 is slightly cooler than our Sun, the planet still sits comfortably in the habitable zone. If Kepler 22b has an atmosphere similar to Earth's, scientists estimate its surface temperature could be around 22 degrees Celsius or 72 degrees Fahrenheit, a perfect spring day by our standards. Of course, that's a big if. Without concrete data on its atmosphere, we can't say for sure what conditions are really like on the surface. But here's the thing. Kepler 22b isn't just intriguing because of what we know. It's fascinating because of what we don't know. Its very existence challenges some of our most basic assumptions about how planets form and evolve. Why? Because planets of its size and position don't fit neatly into categories we've established for celestial bodies. In our own solar system, for example, we don't have any planets that are 2.4 times the size of Earth. We have small rocky worlds like Earth and Mars, and we have massive gas giants like Jupiter and Saturn. Kepler 22b? It's somewhere in the middle, and that middle ground is largely uncharted territory for scientists. So what makes Kepler 22b the alien world that shouldn't exist? It's not just that it defies our expectations, it's that it represents an entirely new class of planets we're only beginning to understand. Its size, orbit, and potential habitability make it a cosmic riddle, one that pushes the boundaries of planetary science and forces us to rethink what's possible in the universe. And the best part? This is just the beginning. As our telescopes and technology improve, Kepler 22b will no doubt become a key target in the search for answers to some of humanity's oldest questions. Are we alone in the universe? And what other worlds are out there waiting to be discovered? Kepler 22b is a reminder of just how much we have left to learn. It's a planet that dares us to imagine the unimaginable, to expand our understanding of what's possible beyond the confines of our solar system. And who knows, one day it might even help us uncover the ultimate mystery, the existence of life beyond Earth. Kepler 22b wasn't discovered by accident. It was the result of years of meticulous observation and an incredible piece of technology, NASA's Kepler Space Telescope. But how exactly do you find a planet that's over 600 light-years away? It's not like we're sending spacecraft to peek through alien windows. Instead, astronomers use a method called the transit method, which is as brilliant as it is simple in concept. Let's break it down. Imagine you're staring at a light bulb, and every now and then a tiny insect flies in front of it. For just a moment, the light dims ever so slightly, and then it brightens back up again. That's essentially what the Kepler Space Telescope was doing, only instead of a light bulb, it was watching over 150,000 stars in the Milky Way galaxy, looking for the faint, periodic dimming that occurs when a planet passes in front of its star. This dimming is what scientists call a transit, and it's one of the most reliable ways to detect exoplanets. In the case of Kepler 22b, the telescope detected 3 separate transits of its host star, Kepler 22. Each time the planet passed in front of the star, it blocked a tiny fraction of its light, just 0.01% to be precise. That's an incredibly small amount, but for the ultra-sensitive Kepler telescope, it was enough to confirm the planet's presence. The timing of these transits also revealed that Kepler 22b completes its orbit every 290 days, putting it tantalizingly close to the length of a year on Earth. But here's the kicker. Just detecting a transit isn't enough to confirm the existence of a planet. There are plenty of other phenomena that could mimic the dimming effect, like stellar activity or even binary star systems where one star passes in front of another. To rule out false positives, astronomers cross-check the data from Kepler with observations from ground-based telescopes and other space observatories. After months of analysis and verification, Kepler 22b was officially confirmed as a planet in December of 2011. It became the first exoplanet ever discovered in the habitable zone of a Sun-like star, a milestone that forever changed the way we search for alien worlds. Now, let's talk about why the habitable zone is such a big deal. This is the region around a star where conditions might just be right for liquid water to exist on a planet's surface. Too close to the star and the planet would be scorched by intense heat like Venus. Too far, and it would be a frozen wasteland like Mars. But in the habitable zone, that's the Goldilocks region. Not too hot, not too cold, but just right. For Kepler 22b, its location in this zone was a key factor that made it stand out among the thousands of exoplanets discovered by Kepler. While the transit method is excellent for detecting a planet's size and orbit, it doesn't tell us much about what the planet is actually like. Is it rocky, like Earth, gaseous, like Neptune, covered in oceans, like a scene straight out of science fiction? The transit method can't answer those questions. It also doesn't reveal whether the planet has an atmosphere, yet alone what that atmosphere is made of. That's why Kepler 22 remains such a mystery. We know it's there, we know it's in the right spot for liquid water, and we know it's about 2.4 times the size of Earth. But beyond that, it's all educated guesses. Still, the discovery of Kepler 22b was a monumental achievement for the Kepler mission. It wasn't just about finding a planet. It was about proving that our galaxy is filled with worlds that defy our imagination. Before Kepler, we didn't even know how common planets were outside our solar system. Now, thanks to discoveries like Kepler 22b, we know that planets outnumber stars in the Milky Way. That's right, there are likely billions of planets in our galaxy alone, and many of them could be in their stars' habitable zones. But let's not forget the challenges involved in making such a discovery. The Kepler Space Telescope had to stare at the same patch of sky for years, gathering data on hundreds of thousands of stars. And even then, spotting a planet was like finding a needle in a haystack. Kepler 22b wasn't the only planet the mission discovered, far from it. By the end of its primary mission in 2013, Kepler had identified over 2,600 confirmed exoplanets, with thousands of more candidates waiting to be analyzed. But Kepler 22b stood out as one of the most promising targets in the search for life beyond Earth. It's worth noting that the Kepler mission didn't just revolutionize our understanding of planets. It also showcased the power of human ingenuity. Think about it. We're talking about a planet so far away that it would take our fastest spacecraft over 10 million years to reach it. And yet, using nothing more than careful observation and clever engineering, we've been able to learn so much about it. The discovery of Kepler 22b wasn't just a triumph of science, it was a testament to humanity's relentless curiosity and our underlying desire to explore the unknown. So how does this all tie into the bigger picture? The discovery of Kepler 22b wasn't just about finding another planet in the habitable zone. It was proof of concept, a sign that our galaxy is teeming with worlds that could potentially host life. And while Kepler 22b remains a mystery for now, its discovery paved the way for future missions and technologies that will help us unlock the secrets of distant planets. Who knows? The next great discovery might just be around the corner. Kepler 22b's physical characteristics place it in a category that continues to fascinate scientists, the super-Earth. Planets like Kepler 22b are larger than Earth but smaller than the gas giants. And while we've identified many of them in the galaxy, they remain something of a cosmic puzzle. Kepler 22b in particular is an especially intriguing case. At 2.4 times the size of Earth, it's far too large to be a purely rocky planet like our own. But it's also too small to be a gas giant like Jupiter or Saturn. So what is it? What's happening beneath its mysterious surface, and what could its size and composition mean for its potential to support life? Let's start with what we do know. Kepler 22b's size puts it in a kind of planetary limbo. In our solar system, we don't have any planets in this size range, so we don't have a direct comparison to draw from. That makes studying Kepler 22b and other super-Earths particularly exciting. Based on what we've learned from studying other exoplanets, scientists have hypothesized a few possibilities about what Kepler 22b might actually be like. One possibility is that Kepler 22b is a rocky world with a thick atmosphere. Imagine Earth, but scaled up and wrapped in a dense layer of gases. A thicker atmosphere could trap heat, making the surface temperature higher than we might expect based solely on its position in the habitable zone. If the greenhouse effect is strong enough, it could even turn Kepler 22b into a kind of super Venus, with scorching temperatures and crushing atmospheric pressure. But here's the twist. If the atmosphere isn't too thick, it could act as a kind of protective blanket, maintaining stable temperatures and potentially allowing liquid water to exist on the surface. The key, of course, is that we just don't know yet. Without direct observations of Kepler 22b's atmosphere, we're left to speculate. Another possibility is that Kepler 22b is an ocean world. Some scientists have suggested that planets of this size might be covered entirely by water with no land masses at all. Picture a planet-wide ocean stretching endlessly in every direction, a world of waves and depths that we can only imagine. If Kepler 22b is an ocean planet, it could have a thick atmosphere made mostly of water vapor, which would create its own unique climate system. But what kinds of life could survive in such an environment? Could alien creatures thrive beneath the waves and oceans deeper and darker than anything we've seen on Earth? If so, how might they evolve in a world with no land, no mountains, no forests, just endless water? Of course, there's also a chance that Kepler 22b isn't rocky or watery at all. It could be a mini Neptune, a small gas planet with a thick hydrogen-helium atmosphere. If that's the case, its surface would be unlikely to support life as we know it. But even this scenario raises fascinating questions. For one, how did a planet of its size and type end up in the habitable zone of a Sun-like star? In our own solar system, the gas giants are much farther out, beyond the frost line where icy materials could accumulate during the early stages of planetary formation. If Kepler 22b is a mini Neptune, it might have formed farther out from its star and then migrated inward. Another mystery that challenges our understanding of planetary evolution. And then there's the question of moons, or rather the lack of them. In our solar system, moons play a significant role in shaping the environments of their host planets. Earth's moon, for example, stabilizes our planet's tilt and influences our tides. But so far, no evidence of exomoons have been found around Kepler 22b. If it does have moons, they could be key to understanding the planet's history and whether it might be capable of supporting life. Without them, though, we're left wondering what role they might or might not play in this distant system. Here's another mind-bending thought. Kepler 22b is so far away that even with our most advanced telescopes, we can't directly observe its surface. What we know comes from indirect measurements: its size, its orbit, and the light it blocks as it transits its star. But that hasn't stopped scientists from running simulations and models to try to predict what conditions might be like on this alien world. And those simulations have given us a tantalizing glimpse into the possibilities. If Kepler 22b has an Earth-like albedo, reflectivity, and no atmosphere, its equilibrium temperature would be around 6 degrees Celsius or 43 degrees Fahrenheit. But if it has a greenhouse effect similar to Earth's, its surface temperatures could rise to a comfortable 22 degrees Celsius or 72 degrees Fahrenheit, perfect for liquid water. Of course, that's a big if. The planet's true nature could be wildly different from anything we've imagined. So what do you think? Could Kepler 22b be a rocky world, an ocean planet, or something else entirely? And what kind of life might evolve on a planet so different from Earth? Let us know your thoughts in the comments. We'd love to hear your theories. What makes Kepler 22b so captivating is its ability to spark questions like these. Its size, orbit, and location in the habitable zone make it a prime candidate for further study. But it's also a reminder of how little we truly know about the universe. For now, Kepler 22b is a blank canvas, waiting us to fill in the details with new discoveries and observations. Until then, it remains a tantalizing mystery, a world that might hold secrets about the origins of life, the diversity of planets, and the incredible complexity of the cosmos. While Kepler 22b's discovery was groundbreaking, it's the mysteries surrounding it that have truly captured the attention of scientists and space enthusiasts alike. This isn't just any planet. It's a world that refuses to fit neatly into our understanding of how planets form, evolve, and exist. Why does Kepler 22b challenge our expectations? Let's dive into the theories and puzzles that make this alien world that shouldn't exist one of the most enigmatic finds in exoplanetary science. To understand why Kepler 22b is so perplexing, we need to revisit its size. At 2.4 times the radius of Earth, it falls into what scientists call the radius gap, or Fulton gap. This refers to the apparent scarcity of planets in the size range between rocky Earth-like worlds and gas-dominated mini-Neptunes. In our solar system, this gap doesn't even exist. Our planets are either smaller, rocky worlds like Earth and Mars, or much larger giants like Neptune and Jupiter. Kepler 22b sits awkwardly in between, defying the categories we've come to expect. Why? Well, one possibility is that planets this size often develop thick atmospheres that make them more gaseous mini-Neptunes. But Kepler 22b's position in the habitable zone complicates things. If it does have a thick atmosphere, why hasn't it experienced runaway heating, turning it into an unimaginable gas world like Venus? If it doesn't, could it somehow have retained a rocky or watery surface despite its size? These are questions that remain unanswered. Another head-scratcher is how Kepler-22b ended up so close to its star while still remaining in the habitable zone. In our own solar system, planets this size, if they even existed, would likely form far from the Sun, where the cooler temperatures allow for the accumulation of icy materials and gases. This is what we see with Neptune and Uranus, which are both icy giants located well beyond the frost line. For Kepler-22b to be this close to its star, it may have had to migrate inward over time, possibly due to gravitational interactions with other planets or remnants of its system's protoplanetary disk. But that raises more questions. How did it migrate without destabilizing the habitable zone? And if it did move, what happened to the other planets that might have been in the system? Did they get ejected into deep space, or are they still out there waiting to be discovered? Then there's the mystery of its composition. If Kepler-22b isn't a rocky super-Earth or a mini Neptune, could it be something entirely different? Some scientists have speculated that planets like Kepler-22b might be hybrid worlds, planets with a mix of rocky and gaseous characteristics that make them unlike anything we've seen before. For example, it might have a dense rocky core surrounded by a thick mantle of water or ice, capped off by a thinner atmosphere of gases like hydrogen or carbon dioxide. If this is the case, it could mean Kepler-22b has a surface that's completely alien to anything we've encountered, with extreme pressures, temperatures, and chemical reactions that would make it a fascinating target for future study. One of the most intriguing theories about Kepler-22b is that it could be an ocean planet. Imagine a world entirely covered in water, with no continents or land masses to break up the endless sea. Such a planet would be unlike Earth in some key ways. Its atmosphere might be dominated by water vapor, creating a humid and warm environment, and its oceans could be incredibly deep, with pressures at the bottom that make our deepest trenches look like puddles. If Kepler-22b is an ocean world, it raises exciting possibilities for life. After all, Earth's oceans are teeming with life, and some of the most extreme environments on our planet, like hydrothermal vents, are home to organisms that thrive without sunlight. Could something similar exist on Kepler-22b? Could alien life forms have evolved in its hypothetical oceans, adapting to conditions we can only imagine? But there's a flip side to this possibility. If Kepler-22b's oceans are too deep, they might lack the geological activity needed to sustain life. On Earth, plate tectonics and volcanic activity play a critical role in recycling nutrients and creating a stable climate. Without these processes, an ocean planet could become stagnant, with no way to support a complex biosphere. And even if life did exist, it might look nothing like what we're used to. Could life on Kepler-22b be microbial, clinging to the bottom of its oceans near thermal vents? Or could it have evolved entirely new forms, unrecognizable to us? Another layer to this mystery involves Kepler-22b's atmosphere, or lack thereof. If the planet has a dense atmosphere, it might trap heat, creating a runaway greenhouse effect that makes the surface uninhabitable. On the other hand, if its atmosphere is thin or non-existent, it could be too cold to sustain liquid water, even in the habitable zone. The equilibrium temperature doesn't necessarily tell us the whole story. After all, Venus and Earth both receive similar amounts of sunlight, but their vastly different atmosphere create wildly different surface conditions. So what's happening on Kepler-22b? Is it a paradise for life, a hellish greenhouse, or a frozen wasteland hiding beneath a thin layer of clouds? The truth is, we just don't know. And here is another twist. Kepler-22b's mysteries aren't just limited to the planet itself. What about its star system? Kepler-22 is a Sun-like star, but it's slightly smaller and cooler than our own Sun, which might affect the planet's climate in ways we don't fully understand. Does Kepler-22b have neighboring planets that we haven't yet detected? Could those planets be influencing its orbit, its atmosphere, or even its potential for habitability? Without more data, the answers to these questions remain elusive. But perhaps the most mind-boggling mystery of all is what Kepler 22b means for our understanding of the universe. If a planet like this exists in the habitable zone of a Sun-like star, how many more are out there? Is Kepler 22b an outlier, or is it part of a common class of planets that we've only just started to discover? And if it is common, what does that mean for the possibility of finding life elsewhere in the galaxy? These are the kinds of questions that keep scientists awake at night, and they're exactly why Kepler 22b continues to be such a fascinating subject of study. So is Kepler 22b a rocky super-Earth, a water world, a mini Neptune, or something entirely new? The truth is we don't have the answers yet, but one thing is certain. Kepler 22b is forcing us to rethink our assumptions about planets and their potential for life. It's a reminder that the universe is far stranger, more diverse, and more complex than we've ever imagined, and that's what makes it so exciting. When it comes to Kepler 22b, one of the most captivating aspects is its potential habitability. After all, the very idea of a planet existing in the habitable zone, the so-called Goldilocks zone of a Sun-like star, sparks endless possibilities. Could Kepler 22b be a place where life thrives? Could it be a second Earth, or is it something even more exotic that challenges our very definition of life? To answer these questions, we need to take a closer look at what we know and don't know about its conditions, and how it compares to other exoplanets that have caught our attention. First, let's talk about what it means for Kepler 22b to be in the habitable zone. This is the region around a star where conditions might allow for liquid water to exist on the surface of a planet. On Earth, water is essential for life as we know it, so finding planets in this zone is one of the key strategies in the search for extraterrestrial life. Kepler 22b's orbit places it squarely in this zone. It's not too close to its star, where intense heat would boil away any water, and not too far where water would freeze into ice. To put it simply, it's in a pretty good spot. However, just because a planet is in the habitable zone doesn't mean it's actually habitable. Take Venus, for example. It's technically within the Sun's habitable zone, but its thick atmosphere has created a runaway greenhouse effect, turning it into a scorching hellscape with surface temperatures hot enough to melt lead. On the other end of the spectrum, Mars is also within the Sun's habitable zone, but with its thin atmosphere, it struggles to retain heat, leaving it cold and barren. So where does Kepler 22b stand? Is it a paradise, or is it more like Venus and Mars? The answer lies in its atmosphere, an element that remains one of the biggest mysteries about Kepler 22b. If the planet has an atmosphere similar to Earth's, it might be able to maintain a stable temperature that allows for liquid water. Scientists estimate that with an Earth-like atmosphere, Kepler 22b's surface temperature could be around 22 degrees Celsius or 72 degrees Fahrenheit, essentially perfect conditions for life as we know it. But if its atmosphere is thicker like Venus's, it could trap heat and push temperatures to inhospitable extremes. On the flip side, if Kepler 22b's atmosphere is thinner or less insulating, this planet could be much colder than expected, potentially freezing out any water that might exist on its surface. The range of possibilities is enormous, and without any direct observations of its atmosphere, we're left with nothing but educated guesses. Now, let's not forget the role of water in all this. If Kepler 22b has significant amounts of liquid water, it could increase the planet's chances of hosting life. Some scientists have speculated that Kepler 22b might be a water world, a planet entirely covered by a global ocean. While this sounds like an idyllic setting for life, it also comes with challenges. On Earth, much of life's diversity is tied to the interaction between land and water. An endless ocean could lack the geological activity, like volcanic eruptions or plate tectonics, that helps recycle nutrients and maintain a stable climate. Without these processes, life on an ocean world might be limited to simpler microbial forms if it exists at all. That said, it's worth considering that life on Kepler 22b, if it exists, might not resemble anything we're familiar with. For most of human history, we've imagined alien life as something similar to Earth life, carbon-based, thriving in liquid water, and requiring oxygen to survive. But what if Kepler-22b hosts life forms that are completely outside our frame of reference? What if its conditions have given rise to organisms that don't rely on water, or that thrive in environments we would consider extreme? After all, even on Earth, life has proven to be astonishingly adaptable. Microbes have been found living in boiling hot springs, under immense pressure at the bottom of the ocean, and even in the vacuum of space. Could Kepler-22b harbor similar extremophiles, clinging to existence in ways we can't yet imagine? To put Kepler-22b's potential into perspective, let's compare it to some other well-known exoplanets. Take Kepler-452b for instance, often nicknamed Earth's cousin. It's about 60% larger than Earth and also orbits within the habitable zone of a Sun-like star. However, its greater size suggests it might have a thick atmosphere, which could make it less Earth-like than we'd hope. Then there's Kepler-186f, a planet only slightly larger than Earth and orbits a red dwarf star. While its size is promising, its star's cooler temperature means Kepler-186f will need to retain heat more effectively to stay warm enough for life. And let's not forget Proxima Centauri b, the closest known exoplanet to Earth. It orbits in the habitable zone of a red dwarf star just 4.2 light-years away, but intense radiation from its star might make it an incredibly hostile environment. Compared to these planets, Kepler-22b stands out because it orbits a Sun-like star, which is far more stable and predictable than the red dwarfs many exoplanets call home. Its size, while puzzling, also gives it unique potential, if its atmosphere and composition are just right. But here's the big question. Even if Kepler-22b is habitable, does that mean it's inhabited? This is where the search for life becomes even more complex. Detecting signs of life, known as biosignatures, on a planet 600 light-years away is no small task. Future telescopes like the James Webb Space Telescope or the upcoming European Extremely Large Telescope might be able to analyze the atmospheres of distant exoplanets for gases like oxygen, methane, or carbon dioxide that could indicate biological activity. However, even with advanced technology, distinguishing life from non-biological processes is incredibly challenging. For now, Kepler-22b remains a tantalizing candidate, but we're far from having definitive proof of life or even the conditions to support it. So what does Kepler-22b teach us about the search for habitable worlds? First, it's a reminder that the universe is full of surprises. Planets like Kepler-22b, with their unique size, location, and characteristics, challenge our understanding of what makes a world habitable. Second, it shows us that the search for life is as much about asking the right questions as it is about finding answers. Could life exist on a planet so different from Earth? Could there be new forms of life that don't even fit our current definitions? These are the kinds of questions that push the boundaries of science and keep us dreaming about what lies beyond. What do you think? Is Kepler-22b a paradise waiting to be discovered, or is it an uninhabitable mystery? Could life exist there, or are we projecting our own Earth-centric biases onto a world that might be entirely alien? Whatever the answer, one thing is certain. Kepler-22b is a reminder of the infinite possibilities that exist in the cosmos, and it's just one of the countless planets that are waiting for us to uncover their secrets. Kepler-22b opens the door to some of the most exciting possibilities in modern astronomy, but it also raises many tantalizing questions that we're still far from answering. As much as we've learned about this distant world, it's clear that our understanding is still in its infancy. So what's next? How do we go from educated guesses about its atmosphere, surface, and potential for life to concrete answers that can reshape the way we view the universe and our place within it? The future of Kepler-22b research is tied directly to the future of space exploration technology, and that's where things get really exciting. The first challenge in studying Kepler 22b further is its incredible distance. At 600 light-years away, we can't exactly hop in a spaceship and visit anytime soon. Even our most advanced spacecraft, traveling at their current speeds, would take millions of years to reach it. For now, our best tools are telescopes, but even those have limitations. The Kepler Space Telescope, which discovered Kepler 22b, was designed to detect planets by observing the tiny dips in a star's brightness caused by planetary transits. This method is phenomenal for finding planets and determining their size and orbit, but it doesn't provide direct images or detailed data about their atmospheres or surfaces. To truly unlock the secrets of Kepler 22b, we need new technology, and we're well on our way. Take the James Webb Space Telescope, the JWST, for example, which launched in late 2021. With its advanced instruments, JWST is capable of analyzing the atmospheres of exoplanets by studying the light that passes through them during transits. If Kepler 22b's atmosphere contains gases like oxygen, methane, or carbon dioxide, JWST might be able to detect their signatures. These gases aren't definitive proof of life, but their presence could hint at biological or geological processes. However, because Kepler 22b is so far away, even JWST might struggle to gather enough data to answer all our questions. That's why astronomers are already looking ahead to the next generation of telescopes. One of the most promising upcoming projects is the European Extremely Large Telescope, EELT, which is expected to become operational in the late 2020s. With a massive 39-meter mirror, the EELT will be the largest optical telescope ever built, capable of capturing incredibly detailed observations of distant worlds. Combined with other powerful observatories like the Nancy Grace Roman Space Telescope and the planned LUVOIR, Large Ultraviolet Optical Infrared Surveyor, we'll have an unprecedented ability to study exoplanets like Kepler 22b in greater detail. These tools can help us determine whether the planet has an atmosphere, what that atmosphere is made of, and whether its conditions are truly suitable for life. But even as our telescopes improve, we're left with one of the most profound challenges in planetary science: interpreting the data. Let's say we find evidence of water vapor in Kepler 22b's atmosphere. Does that mean it has oceans, or is the water trapped in clouds or ice? Or imagine detecting methane. On Earth, methane is often produced by life, but it can also be created by volcanic activity. Interpreting these signals requires careful analysis and sometimes a leap of imagination. As much as we're advancing our technology, we're also expanding our understanding of what's possible, and that's just as important. Kepler 22b is also shaping the way we think about exploration itself. While visiting this distant planet is far beyond our current capabilities, it's inspiring new ideas about how we might one day reach worlds like it. Concepts like interstellar spacecraft powered by solar sails or laser propulsion are being actively researched, with the hope that one day we might send probes to other star systems. Even if these missions are centuries away, the very act of dreaming about them pushes the boundaries of what we think is possible. And who knows, by the time we develop such technologies, Kepler 22b might not be the only target. We could have a whole catalog of potentially habitable worlds to explore. But perhaps the most exciting thing about Kepler 22b is what it represents. This single planet, orbiting a distant star, is a reminder that the universe is full of surprises. When we first started searching for exoplanets, we weren't even sure if they were common. Now, we know that planets outnumber stars in the Milky Way, and many of them could be in their stars' habitable zones. Kepler 22b is special, not just because of what it might be, but because of what it symbolizes: the endless possibilities that exist in the cosmos. It's a world that defies our expectations, challenges our assumptions, and reminds us that we've only just begun to scratch the surface of what's out there. So where does that leave us? Kepler 22b is a mystery waiting to be unraveled. It could be a rocky super-Earth, a water world, or even something entirely new that defies all our definitions of planets. It could be a paradise for life, or an uninhabitable world that still holds insights into how planets form and evolve. Whatever the case, Kepler 22b is a reminder of the boundless potential of exploration and discovery. It's a world that asks us to dream bigger, to think beyond our own experiences, and to imagine what's possible in the vastness of space. And that's the beauty of Kepler 22b. It's not just a planet. It's a question, a challenge, a gateway to the unknown. As we continue to study it and other exoplanets, we're not just learning about distant worlds. We're learning about ourselves, our place in the universe, and the incredible power of curiosity. Who knows what we'll find next? Maybe it'll be another Kepler 22b, or maybe it'll be something even stranger, something that pushes the boundaries of what we thought was possible. One thing's for sure, the search has only just begun. If you've enjoyed this deep dive into the mysteries of Kepler 22b, don't forget to like this video and subscribe for more cosmic explorations. And as always, stay insanely curious.